All right, so Riley, take a look at this equation here. This equation has a shift left and right because of that addition right there. That +5 actually shifts the parent graph left 5. And this -3 at the outside, at the end of everything, that moves the parent graph down 3. Now what we're going to do is we're going to get rid of those shifts. We're just going to make a table of values for 1/2 e to the x. Now the reason we do that is because if we just made a table of values and used these right here, our table of values almost always consists of -2, -1, 0, 1, and 2. But because of these shifts, it's not going to get the important information of the graph with those values. So if we do a non-shifted version, we can still use -2, -1, 0, 1, and 2, and we'll get nice, reasonably nice numbers. But then to get what the graph actually looks like, after we plug these in, and you're going to want to use a calculator with the E button. I can show you what that looks like here in a second. So you'll grab your calculator and punch these in, 1/2, and then you'll have an E button somewhere. It always has an exponent with it. So mine's a second button. And then we got 1/2 and then e to the -2. And I get 0.067. So I'll just go 0.07. And then 1/2 e to the -1. So we'll say 0.18. Pretty small. And then anything to 0 power is 1, and then 1/2 of 1 is 1/2. And then 1/2 e to the 1, 1.36. And finally 1/2 e to the, what was it? Oh yeah, 3.70. So then you go to your graph paper, or in my case, just a graph, and you plot these points. So -2, tiny. -1, pretty small. 0 up 1/2. 1 up 1.36, so about 1.5. We'll gauge it. And then finally we've got 2, which is up to 1, 2, 3, 4, but we're going to go 3.7, so a little bit closer to the 4. Now this would make a nice exponential graph if I connected it, but it's more closely related to the parent graph rather than the actual graph that we have here. So what we need to do is we need to take each of these points and shift them. And this is always opposite when it impacts the x. So it's going to be shift left 5 and down 3. This is vertical shift. This is a left-right shift, but it's opposite of what you think. So each point we're going to go left 5, down 3, left 5, down 3, left 5, down 3, left 5, down 3, left 5, down 3. And then we also need to keep in mind that our asymptote moves down 3. And now we've got the accurate graph like so. So you always want to do the non-shifted graph first, table of values. It's going to make these numbers nice as far as, or it's going to make the calculations nicer than if you use these. And then you just got to make sure to shift everything. And there you have it.